So once again, welcome to the review videos for Shaughnessy's class for Math 30-2. This is Exponents and Logs lesson 14. It's not a terribly difficult lesson. The only thing is it does require the use of a calculator. So please make sure you have your TI or 83 or 84 or whatever nearby. If you have a different model of calculator, the calculator steps are different, so please come see me or consult your manual. Otherwise, let's go. So regression. Now what regression is it's using technology to come up with a curve of best fit, an equation that models a set of data. This is one where you just have the list of data, and in going through and finding the relationships or finding the patterns like we were doing in the last couple lessons, we haven't done that yet, or we don't see the patterns yet, or it's just the data is too unrounded to really see the patterns by themselves. So what I've just got is this huge list of data. Now there are lots of ways to create regression equations, and in fact they all can be done by hand. There's least squares, there's median, you name it, there's all sorts of different ways to do it. We're just using the calculator to create regression equations. Now, the steps are as follows. Okay? You want the equation that models the context. In the 83-84, you're going to put data into your lists. That's what it's trying to say here. The lists are basically kind of like a spreadsheet of where you can put points data. Okay? Your time list or your X list will be in L1. Your value list or your Y list will be in L2. Now, where do you get that? Well, I'll show you in a minute, but you push the stat key and then edit. Okay, so I'm going to put that right here, stat. Okay, and then you're going to choose 1:edit. And from there, you're going to have a series of lists. Okay, from there, you're going to perform an exponential regression. Okay, to find the exponential regression, you're going to push the stat key again. And then you're going to push the right arrow key, okay, which is just in the arrow pad, the right arrow, and that will allow you to get into there. You'll find X per egg. When you do that, stat calc menu of the calculator, copy the equation so that it can be used as the model. Keep in mind it'll pull up, if you've got a new operating system, to pull up a weird menu. Then you copy out the equation, and then you just do what we did before. Basically all you're doing is you're taking the list of points and you're using them to create an equation. Okay? So here are some examples. Here's what I mean. Okay? Example. This one comes out of the standards document for Math 30-2. A researcher discovered mold growing in a petri dish. I'm going to refocus this just to help. Discovered mold growing. When first observed, the mold covered 3% of the dish's surface, and every 24 hours the surface of the mold doubles in size. So after 24 hours it became 6, and so on and so forth. It's shown in the table below. Complete the table below. So I'm going to do that. 24 hours later it's doubling, so 6 times 2 would be 12, and 24 hours later it's doubling, so 12 times 2 is 24, and so on and so forth. Okay? So I've got this particular data. Now, I could go through and create an equation for this, but what I'm going to do is use your determine an exponential function. Okay, so I'm going to, well, I could do it by hand, or I could use the calculator, and here's what I'm going to do. So moving that a little bit over, okay, step 1, enter them in the lists. Okay, I'm going to back this up a bit because I want you to see what I'm doing. Okay, step 1, enter it in the lists. So here I push the stat key. Stat is right here. So I turn on the calculator, I push stat. Okay. Once I get stat, then I've got this menu that shows up. I choose number 1 for edit, so I just hit enter. And I've got lists. Now you may have numbers in them, you may not. In fact, if you've never used this before, you probably don't. Okay. If you do have numbers in them, scroll up to the top. Okay. Then push the clear button. Clear is right here, not delete. The clear button. You have to push the clear button and hit enter. And that's what's said and done. And then you go through L2, clear, enter. And it'll clean them out. Okay? After you've done this example, you will have numbers in them each time. So you'll have to remember this clear and enter idea. Okay? Now, what I'm going to do is I'm going to put the time in L1. So I'm going to put these numbers in. 0. And all you do when you've got one, you hit enter and it goes to the next one. 24. Enter. Okay? 48. Enter. 72. Enter. Going into my L2, and I just use the arrows to navigate. That one's got to be 3, then 6, then 12, then 24. Now, one thing to keep in mind is you have to have the same number of numbers in each list. I've got 4 things in L1, 4 things in L2, so it's all good. If you get errors like error, dim, mismatch, etc., you've probably got one more or something in one than you do in the other. You have to have the same number. Okay. From there, okay, I put that in L1. That was step 1. Step 2, perform exponential regression using the X list as L1, the Y list as L2. To get into that, push Stat again, and then push the right arrow into Calc. And it's in here where you've got XBREG. In fact, it's option 0. Okay, trying to make it show up better on the screen. XBREG option 0. You pull that out and it brings up this menu. Okay. Your X list should be L1. If it isn't, to get L1, you push second and the number 1. And that's where L1 is. The Y list should be L2. If it isn't, second and the number 2. Okay. You won't worry about frequency list. You won't worry about storing because we're not worried about that. And then calculate. Okay. So once that's done, calculate. And it will pull up a window like this. Now what it's telling you, now you probably won't have R squared and R, so don't worry about that. But what it's telling you is that the equation looks like y equals a times b to the power of x, which is what we were doing the other day. It's telling you that the a is 3 and the b is 1.029302237. Okay? If it says round, round. If it doesn't, then don't. So continuing on, my equation is going to be y equals, my a value is 3, my b value is 1.029302237 to the power of x. Excuse me. Once that's done, there's my equation. Now that you've got the equation, B, use your function from part A to determine the approximate length of time to the nearest tenth of an hour it will take for the Petri dish to be completely covered. Keep in mind you've got 2 values that you don't know, y and x. Those are your 2 variables. It wants to know time, which is x. It wants to be completely covered. The percentage that's covered is y. So you want 100%, and then from there, sorry about that. I paused it because of the coughing, so I apologize. From there, you just solve it the same as we did before. The key thing is remembering the regression. Okay, you're using the calculator or the technology in order to create your equation. Okay. If I go on and look at the second one, okay, in this one here, Corleen invested money in a GIC. The value of her investment for the first 3 years is shown in the table below. Okay, so I've got this table. To model the investment's growth predict its future value, Corleen has chosen to use an exponential model. Discuss the effectiveness of her model. Basically, when you talk about this, it's increasing at a constant rate. Therefore, it's a good idea. because it's increasing by a certain percentage each time, so that's good. Write an exponential function that Corleen could use to predict the future value of her investment. So this is now wanting me to do a regression. So from there, clear up my calculator. I got to put my data in the list. So stat, choose number 1 for edit. There's numbers in there, clear and enter. Numbers in there, clear and enter. Okay. Go through with this. I'm going to put in the time in list 1. So I've got 0, enter, 1, enter, 2, enter, 3. In L2, I'm going to put my value, so it's going to be 1,000, 1,020, 1,040, and 1,061, 21. That's 1,040. I entered this wrong. 0.4, so I'm putting that in. Okay? So I've got this data. Now that I've got it in my X list and Y list, or my L1 and my L2, I push stat again. Okay, stat. Go over to the right, and I'm going to look for XREG. Now remember, it's option 0. So I'm going to pull that out. It brings me up this list. My X list has got to be L1. My Y list has got to be L2. It is, so I don't have to worry. Okay, calculate, hit enter. It thinks for a while, it gives me this. Now keep in mind, you don't have R squared or R. You'll have these particular values. Now, going through, I know it's y equals something times something to the power of x. So y equals a times b to the power of x. And I'm going to put in those values. It tells me that a is 999.9996231. Okay, the B value is 1.0200000577, and there's my equation. So I've got 999.999 times 1.02 blah 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 to the power of x. So there's my equation. In C, explain what the values represent. Well, the A value, keeping in mind, the A value is the starting value. Okay, so it's not exactly, because I know I had $1,000 to start if I look back at the table. It's saying it's $999.99.962. That's $1,000. The other thing here is this particular value is called the rate of change. And from there I can see that the rate of change, I end up with 102% each time, or it's growing at 2% per year. Okay, so I can go with it from there. Now along with this I can say, okay, if Corleen invested in a GIC that paid 1.4% compounded annually, how would this affect the value of the investment? Well, I'm growing at 2% per year. If I turned and said, you know what, the heck with this, I'm going to invest in 1.4%, I'm getting less. This would decrease the value, okay? Because I'm getting better than 1.4%. I'm getting 2%, which is actually fantastic in the modern world. So 1.4% would be less, so this would decrease the value. Over time, this would decrease the value of the investment because I am getting 2. Okay, I'm already getting 2. Why would I change it and get less? Okay, and so that's the situation there. So this is exponential growth or regression or rate of change, etc., etc. Logarithmic regression, same basic idea. Okay, I'm going to go zoom in here a little bit. Going through with this, logarithmic regression. Okay, I'm going to refocus. If it's not exponential, you can have anything. You could have linear, you could have quadratic, and we will get to that later. But sometimes you have a logarithmic. Okay, so in this situation, we do that. Logarithmic regression involves base E. Now, E. Here's the issue with E. Okay, E is a very formal number. It's called Euler's number. It says that under here. E is Euler's number. Okay, EULER is Euler, okay, just like the hockey team. It is 2.71828, etc., etc., etc. I don't want you to know anything more about that. If you had taken calculus, if you had taken Math 30-1 or 31, AP, etc., etc., in calculus you explore the nature of E and what it means to be E, and you can look at all sorts of infinite sequences and series that give you the value of E and why E is special and all of that. E is special in the same way pi is special. Pi is 3.14159, da 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 da. You know that. Back in junior high, you used 3.14, and that's where you stopped, and that's what you used. Okay? You've never really looked at why pi is pi. Okay? The same thing goes with E. That's what I want you to do. E is 2.71828 or 2.71. It's special, and if you want to know more about it, come ask or take calculus. So don't worry about it. But E is special. Now the reason I mention E is because it uses a log base E. Now if I look at my calculator, we've been using the log button, and I've said repeatedly this is log base 10. I've never mentioned the button that says ln. ln is what's called a natural logarithm, a natural log. It's a log base E. They're both logs. One is base 10, which makes more sense. The other is base E, which shows up in the natural world. You are the only class besides calculus in all of high school that you looks at E. Okay, nobody else does. So don't panic about it. Don't think, well, you're going to see this in other classes. You're not. But when the calculator does regressions, it only does regressions in terms of base E. I don't know why. It doesn't have to, but that's how the calculator manufacturers work. And it doesn't matter whether you're using a TI or a Sharp or a Casio or an HP or whatever else. All the logarithmic regressions are in terms of base E. So you're going to be using natural logarithm. Okay, you're going to see this ln. It just means natural log. Okay, so that's how I'm going to say it. And it's a log base E. Don't panic about it in any way, shape, or form. It's just a different button. It's a log base E. That's all you need to know about it. Now from there, you enter the data into the calculator. Time is in L1. Value is in L2. That's no different. The only thing is, instead of choosing expreg, you're going to choose lnreg, natural logarithmic regression. Okay? X list is L1, Y list is L2, same as before. Copy the regression and answer the question. So in this particular case here, here's an example. Okay? When objects of different masses are compared without a scale, to be perceived, the difference in mass must be large enough. Okay, you pick it up, it has to be a big enough difference for you to notice that, hey, it's heavier. Okay, if it's not noticeably different, you don't notice that it's heavier, even though it actually is. For example, when held in a person's hand, different masses within 5 grams of 100 grams do seem to be the same. So you could hold a 95 gram mass, 100 gram mass, and 105 gram mass, and the average person can't tell the difference between them. The 5 gram difference is known as the minimum perceivable difference, and as it gets heavier, 5 grams gets, and it changes. Okay? For heavier objects, the minimum perceivable difference increases. The minimum perceivable differences for various masses are shown in the table below. So you've got this situation. Okay? It's not time, but this is your X, your mass. This is your Y, your perceivable difference. It's always going to be set up. Okay? So from there, you've got to enter this data into your calculator. So same as before, turn it on, clear out whatever's there, push the stat button, choose edit, clear out what's there, clear and enter, up, clear, enter, okay, get that there. And from there, I'm going to put in the values. So L1 is 100, then 200, then 400, then 800. L2 is going to be the minimum perceivable difference. So 5, 10, 15, 20. Once again, same number of numbers in each list. From here, I'm going to push stat, Go over to Calc, and I'm going to scroll down till I see LN Regression. LN Reg, that's option 9. So I pull that out, pulls up this menu. X list is L1, Y list is L2. I'm going to get it to calculate. And when I do, it tells me it's of the form y equals a plus b natural log x. They'll give you that here, okay? And if I look at this screen, now keep in mind you once again still don't have r squared and r. But it tells me a is negative 28.21928.095 and b is 7.213475.204. I know it doesn't show up on the screen so much. But from there, then what I do is I just copy it out. So y is equal to a, which is negative 28.21928.095, plus b, which is 7.213475204, times the natural log of x. Okay. There's my equation. Written out just to make it neat. Okay. I'm going to get that y is equal to negative 28.21928095 plus 7.213475204 times the natural log of x. That's what it's giving me. That's my equation. And from there I could use it, keeping in mind that my y is my minimum perceivable difference, my x is the mass in question. So from there I could do all sorts of questions from there. For example, B, based on the regression equation, determine the minimum perceivable difference. I have y, I have x. Keep in mind the minimum perceivable difference is x. X is the mass, which is 2100. So I'd use my equation and I'd solve from there. The key thing is when you go to type it in, okay, you've got y equals negative 28.21928.095 plus 7.213475.204 times the natural log of x. Okay, just rewriting that. Okay, I know x is 2100, so I'm going to put y is equal to negative 28.21928.095 plus 7.213475204 times the natural log of 2100. And when I go to type that into my calculator, I go, I'm just showing it here, negative 28.21928.095 plus 7.213475204 times, you use the natural log, this button here. Okay, you use this button here, the natural log, ln. So times the natural log of 2100. If you use just log, it doesn't work. When you do that, the minimum perceivable difference is 26.96. So y is 26.96 grams. Okay? You have to use the natural log button in order to use the natural logarithmic regression. So all in all, that's what it boils down to. You're much more likely to see exponential regression than you will be logarithmic regression. There's a lot more situations that use exponential functions than logs, but nonetheless it could be there. So please make sure you know both regressions. You've got some homework. If you have any questions or you're not sure what's going on in your calculator, please just ask. I can write out more notes. Best wishes.